Good morning to all. Myself Rekha, Assistant Professor, Department of Mathematics. So my course is nothing but a discrete structure and optimization technique. So under that discrete and optimization technique. So previous class we have discussed about the logical thinking, logical connectives, etc. And this class is nothing but northwest corner method. This northwest corner method is a specific method in transportation problem. So first of all, I am going to explain what is transportation problem. Transportation problem is nothing but a specific type of a linear problem, and in this transportation goods should have on various transported to a various destination based on the supply and demand. So there are the 2 points two types based on the transportation problem. One is balanced transportation and another one is unbalanced transportation. If it is in balanced transportation, the supply should be equal to the demand, whereas unbalanced transportation, the supply need not be equal to the problem. So now first we will consider what is meant by northwest corner. Shortly we will say it is an NWC. This method is helps to find the initial basic feasible solution for the transportation problem, and it is an interesting one also. So using this problem we can minimize the transportation cost also. We have the three methods. So this is one of the method, starting method to find the initial basic feasible solution. And let us start the procedure. So first of all we have to consider the northwest corner cell. We have a lot of cells in that. We have to consider the northwest corner cell. In that we have to assign the supply and demand value according to the minimizing supply value, and also we have to enter the minimum value either to the corresponding rows and the columns. So finally we have to cross down and we have to follow all the procedure until we have to repeat all the supply and demand based on the zeros. So now consider a northwest corner rule. So you have to check in this problem whether it is a balanced transportation problem or not. So if it is a balanced transportation problem, we can continue the problem. For example, you have the supply as 250, 300, 400, and here demand as 200, 225, 275, 280. We will add all those things. The value of the total supply is nothing but 950 and total demand is also 950. It is equal, so we can continue the problem. And first of all, we can go with the difference between the supply and demand. We have to choose the northwest corner cell. If it is a northwest corner cell, and we can allocate the value, so we can see which is the minimum value, supply and demand. So supply is 250 and demand is 200, so we have to allocate the minimum value 200 here. Then subtract the 250 minus 200, you will get 50 balance, and similarly cancel that row, cancel that column. Then we can continue to the remaining values. Again consider the supply and demand, which is the minimum we have to allocate. So here the minimum value is 50, we have to allocate. Then subtract the remaining value, continues from the rows and columns. So we have to repeat the procedure until the rows and columns will get cancelled, and finally we will get an only one cell. In that it should be a balanced one. So like that we have allocated the all the rows and columns based on the minimum value of the supply and demand, and finally we will get an transportation cost based on the minimization allocation cell. So the transportation path also we have got it. So the transportation cost we have to find it as 200 into 11, 50 into 13, 175 into 18, 125 into 14, 150 into 13, 250 into 10, and based on that we will get an answer as